All right, I was at Anchor Electronics this morning, and if you're lucky, every once in a while there's a free box on the outside. As you walk into the building, just in front of the front door, there's sometimes a free box. And I looked through the free box today and I found this, so I thought I'd make a good video. You go, well, what is that? Is that one of those carcinogenic filled capacitors? It's labeled 1 and 2. That's always good. It has mounting lugs on the bottom. It was inspected in 1962. Yeah, 1960. Where's my magnifier? Here it is. Yeah, 1962. Yes, very nice. So, any guesses? Any guesses? Here's a nice seam in the, it's very heavy. Very, very heavy. All right, so everything you wanted to know is printed right on the device, which is always nice. All right, so right away we can see a picture of it. It's a coil. All right, this is a C-344366 TF4SX04YY. Looks military. Maximum working voltage to ground, 428 volts. 15 henries minimum. 130 milliamps maximum. DCR resistance, something resistance, 75 ohms. 10 volts at 60 hertz. Interesting. That must be the measurement conditions. I'm not sure. Maximum altitude, 18,000 feet. That gives you a clue. This is probably on a bomber or something, military jet. 18,000 feet. The Freed Transformer Company, Brooklyn, New York. Are they still there? All my friends in Brooklyn, shout out if you know where the Freed Transformer Company is. I doubt that it's there. It's Freed number 33148, if that helps, instead of these military numbers up here. Anyway, yeah, 15 farads. That's pretty heavy duty. And it seems like a lot of copper in here because it's heavy. So can my device measure 15 farads? Or will it measure it? I think it will measure it. Okay. So let's hook up some probes. Thinks it's something. Millihenries. 1600 millihenries. That's not 15 farads. 15 henries. 15 henries. 15 HYs. We're testing at 1 kilohertz though, so let's change the frequency. 10 kilohertz, it's measuring 17. 100 kilohertz, it's measuring... it's measuring... It's very confused. It doesn't like that. 100 hertz. 100 hertz. So there we go. Look at 100 hertz. 2 farads. Farad. I keep saying farads. 2 henries. Yeah, 2 henries. That's pretty good. It's certainly not 15, but this is at 100 hertz. And the test conditions were 60 hertz. At least that's how I read the labeling. Let's go to 120 hertz and see if it changes a lot or not. 120. That's about 2 henries still. And then we go to 1 kilohertz and it's back where we were. So anyway, yeah. Oops, sorry. There we go, 100 hertz. So 2 henries. I'm not sure about that 15. I'm just not sure about that 15. Shout down below if you know that when it gets up to this type of range, is the measurement technique different? Or I should say maybe not the measurement technique, but is the specification different? Is the way these are specified, and I guess measured, is it that different? It's kind of interesting. Oh, we didn't measure the the resistance, so let's do that. I'll go back up. Oops. There we go. R's. Oops. Can you see that? 157 ohms. So, what did it say on the front? 75 ohms max. Yeah, I'm not quite sure. Very interesting. Let's see what the ohms read at a different frequency here. That's 100 hertz. 120. Oh yeah, it's going up. Yeah, I bet you it's 60 hertz. It just measures a whole lot different. That's interesting. I say we use a different instrument to measure this. I think I have just the thing. Hang on. So what do you measure military devices with? A military tester. So yeah, let's use my ZM11U bridge. It's a nice bridge. Does it go to 15 henries? L's, millihenries, 10 henries. It has a 10 Henry scale. I don't know. Give it a try. Let me plug it in. All right. Let's see. L's. 10 Henries. Let's see. L's go between these two. All right. Oops. L's go between these two, and then we'll hook up our device. All right. Okay. I'm measuring 2. I think I'm measuring 2 henries, which is what we measured with the other one. I don't think that's... Let's see here. Millihenries, 1 millihenry, 0.1 millihenry, 0.1... All right, I'm going to measure this right here. We're measuring 1 kilohertz, so let me show you how I'm doing that. I'm using my HP count, or DVM actually up there, but it has a frequency meter built in, and it's measuring a 1 kilohertz. So we have a 1 kilohertz test, 1 kilohertz test signal. So we should be measuring about 2,000 millihenries, right? 2 henries. 2 henries. So, yeah. Let's see. No, was that right? Yeah. Now I'm getting confused. All right, let's try that one again. Yeah, at 1 kilohertz, we were measuring 1.7 henries. 1.7 henries. Okay. And then at 100 hertz, we're measuring 2 henries. So with this machine, we are measuring 2 henries at 1 kilohertz. So they're a little bit different from one another. I know I've covered this many times before, but let me zoom in on it a bit. You set the mode of operation here. C, L's, and R's are the multipliers. Up here, it just depends on how you attach it to the bridge. Resistors, so capacitors, you would attach across these two. Resistors, inductors, and transformers, you attach against these two. So that's where I have it attached here. You select what type of test you're doing here, whether it's a C or an L or an R. I have it on L. And then you watch the magic eye tube open up. And can you see that? I think you can. So it's closed now, and now it's open. So you make it maximum width. Can I change the camera down so you can see that a little, maybe a little bit? Oops, too far. Too far. Maybe you can see that a little bit better. Anyway, you make it a maximum opening, and that's when the bridge is happy. Anyway, I don't know how they get 15 farads, but again, this doesn't do 60 hertz. But even the difference between 1 kilohertz, 120, and 100, I don't think 60 really gets you to 15 farads. So, yeah, I'm skeptical of this thing, and I don't know how that would go bad. I have no idea how a inductor would go bad. Unless it's 1.5 henries and they forgot the little thing in there. Let's see. That's 15. 15 henries minimum. Minimum. Yeah, I don't know. Anyway, comment below. What am I doing wrong? What am I doing wrong?